All right, so in this video, we want to find the equation of the tangent lines of these two equations at the given points. And we want to do it using first principles rather than quick derivation. So it's a bit of practice of first principles. So the first thing we want to do is we want to find the slope, and we're going to use our first principles equation. So that's lim h approaches 0, f of x plus h minus f of x divided by h. So we have to basically sub in for these equations over here and then solve this. And the solution to this is basically going to be the slope of our tangent line. Okay, so let's start filling in this equation. F of x plus h, I'm going to rewrite this equation over here. But I'm going to replace the x with x plus h. So that's 4 minus x plus h square minus, then f of x is just the original equation there. Make sure you write it inside a bracket if it has multiple terms. And then we're dividing by h. So I've just filled out this equation here with that equation. And now I guess we can solve this equation. You can sub in the point -2 right now, I believe, for x. If you want, it'll simplify things a bit. Or you can just solve it like this and sub in the point later, which is what I do. But either way, the answer will be the same. So in the next step over here, I'm going to expand this bracket out. Basically, I'm going to FOIL out this bracket, but I'm going to do it a bit quick because you don't want to waste time in calculus. So it's x squared plus xh plus xh, which is 2xh, and then plus h squared. And then this bracket just stays the same, 4 minus x squared, and then we just have divided by h. The next thing you want to do is want to distribute these negatives into these brackets. 4 minus x squared minus 2xh plus h squared minus 4 plus x squared divided by h. And then 4 and -4 cancel out. Negative x squared and positive x squared cancel out. So I'm just left with lim h approaches 0, negative 2xh plus h squared divided by h. And now I can just cancel an h from all three terms. You could factor out as well, but I'm going to save a bit of time, just cancel it like that. So I'm just left with negative 2x plus h, and then I'm going to sub in, once I cancel out the h's, I can sub in h as 0. So that's just negative 2x. This is basically the slope of the entire equation. And now we want to find the slope at x equals to -2. So my slope of the tangent line is -2 times -2, which is positive 4. Once I find my slope, I want to find the entire equation. So I'm going to use y equals mx plus b. I know that the slope is 4. And now I can sub in the original point back into this equation to find my b. So y is 0 and x is -2. So b is just positive 8, which means my equation is y equals to 4x plus 8. This is the equation of the tangent line. Now I'm going to just sketch this entire situation out so you understand what's going on. Over here, you see I have a quadratic equation y equals to 4 minus x squared. 4 minus x squared, you should be able to sketch it instantly. The vertex is at positive 4 and the graph opens downwards. Now we want to find the equation of the tangent line at -2 and 0, which is over here, the x-intercept. And this tangent line just looks like this. And we found the equation over here, y equals 4x plus 8. So this y-intercept over here is positive 8. And the slope of this line, as you can tell, it's pretty steep. The slope of this line is positive 4. Let's take a look at the second example. This is a cubic one, so it's going to be a bit more difficult, a lot more simplification. Let's start by subbing it in this equation over here. So lim h approaches 0, 1 minus x plus h cube minus 1 minus x cube divided by h. The rest of the steps are all the same, except instead of foiling out 2 brackets, we're going to foil out 3 brackets over here. So I'll do that really quick. Lim h approaches 0, 1 minus the first bracket, I'm going to just write it the same. And if I foil out the second bracket twice, I'll get the same thing over here, which is x squared plus 2xh plus h squared. And then I have minus, I'll distribute this negative into this bracket, so minus 1 plus x cubed divided by h. This 1 and negative 1 cancel. So now I'm going to FOIL out these 2 brackets over here. So lim h approaches 0. Don't forget this negative sign over here, x plus h. Whoops, what am I doing? All right, down here, negative. I'm going to FOIL out these 2 brackets. So x cubed plus 2x square h plus xh square plus x square h plus 2x h square and then plus h cubed. And I close the bracket, and then I have the plus x cubed out there. And all of that is divided by h. Could barely squeeze it in that line, but there you pretty much have it. So now I'll combine like terms inside this bracket. So lim h approaches 0, negative x cubed, 2x square h plus x square h is just 3x square h. Xh square plus 2xh square is 3xh square. And then I just have the h cube over here at the end and the plus x cube over here. I'll distribute this negative into this bracket now. So I have negative x cubed minus 3x square h minus 3xh square minus h cubed plus x cubed divided by h. Negative x cubed and positive x cubed cancel out. And then I can now divide h and get rid of an h from all the terms. So this cancels with that. This becomes a 1. This becomes a 2. I'm left with lim h approaches 0, negative 3x squared minus 3xh minus h squared. Now I can sub in h as a 0 into this equation. So this will just, these two will become 0. You're just left with negative 3x squared. The derivation of this equation is negative 3x squared. Now I can find the slope by subbing in the x value of the original point, which is 0 in this case. Now sub in 0 into this. The negative 0, 3 times 0 squared is just a 0. So this equation doesn't even have a slope. It's just going to be a horizontal line. Okay, so y equals mx plus b. Obviously, no slope exists, so y is just going to be b. And if I come back over here, I know that the y value is 1 when x is 0. So y is 1, so b is just 1. So my equation for this tangent line is just y equals to 1. It's a horizontal tangent line, which is possible. I'll sketch the situation out as well so that it makes sense to you. So 1 minus x cubed is just an x cubed graph that's flipped in the x-axis and it's moved up by 1 unit. So I know an x cubed graph is normally like that. It's flipped now and it's moved up by 1 unit. So it's going to look something like that. This point over here is the point 1, 0. My tangent line is a horizontal tangent line. So this is basically a stationary inflection point. So if you don't know what it is now, you will learn it later in the course. That's what the tangent line looks for this one. And that's basically the graph of the original function and the tangent line.